Alright guys, we're just going to do a little bit of a longer solve for a conversion factor problem, and we're just going to kind of carry this one out and see what you think. And go ahead and follow along if you want. We have 231 miles per hour. Okay, so we normally would see this in the format of 231 mph, right? But we can rewrite that as 231 miles, right, per 1 hour, right? We're going to go ahead and put that in parentheses, okay? And I'm thinking I'm probably writing a little bit big here, so I'm going to write the rest of the solution a little bit smaller, but you should be able to see it just fine to follow along. So we have 231 miles per hour, and what we want to do is we want to get it to meters per second, because meters per second is the SI form of notation, right? Those are the SI units, the international standard for scientific data, okay? Something like that. So you're going to get used to converting things to metric and then boiling it down from metric to meters per second. So you wouldn't even really use kilometers per second. You would always want to bring it back, unless otherwise stated, to meters per second, right? Okay, because meters is the SI unit for length, the standard international scientific measure for length, okay? So 231 miles per 1 hour, and we want to get it to meters per second. So right away, what I personally would think of is, well, what's a metric measurement that's close to miles? Meters isn't very close to miles. So what I would probably do is go with kilometers. So I'm going to put kilometers here in the numerator position, because that's the value I'm after. And I'm going to put miles in the denominator, because I'm looking for how many kilometers in a mile. And a good way to remember that is we move diagonally like this. This allows us to cross cancel the miles, that unit of measurement, right? And so 1 kilometer has, and you'll learn certain measurements will just be stuck in your memory. So that's 0.62 miles, 0.6214 miles per 1 kilometer, okay? So we have 231 miles per hour is what we started with. We're converting it to a metric measurement here in terms of the length. We're just focused on the length right here. And so we put what we're after in the numerator position, 1 kilometer, and that is 0.62 miles. That is the relation of kilometers to miles, which are represented in our original value, in our original measurement, right? And so we're going to come up and we're going to move on down, because now we want to get to meters. So now we're going to be after kilometers diagonally, right? We're going diagonal. There's 1,000 meters in a kilometer, right? In a single kilometer. And we can see, boom, cross-canceling that unit of measurement, aren't we? Everybody tracking? Moving diagonally, putting the value we're after up on top. So now we've already gotten it down to the length. We've converted from, once this is carried out, we'll have converted from miles to meters. But now we still have to account for time, right? So I probably should pause here, rewrite this a little bit smaller so that it makes sense. All right, so again, we start with 231 miles per, right, here's the per 1 hour. We converted that to the metric system, the closest measurement we could think of, which was kilometers, right? So we put what we were after in the numerator position. 1 kilometer is 0.62 miles. See, we move diagonally, right? So we can cross cancel here. And now let me switch to red, and we're going to cross cancel kilometers right there. See, cross canceling those units of measurement, right? So now we've got to the point where we're at meters, which is what we were after. So now we need to look at getting to seconds. We're still in the hour range, or we're still under the hour unit of time measurement. We want to get to the second unit of time measurement, right? So we'll rewrite what we have, 1 hour, right? And then we're going to relate that to a smaller unit of measurement. We're not going to go metric just yet. We're going to stay minutes, 60 minutes, okay? 60 minutes per 1 hour. Okay, that's easy enough. We're just getting it smaller so that we can then convert. Now, remember that multiplication is commutative. So this is being multiplied against this bit in parentheses, and this bit in parentheses, and this bit in parentheses, right? So parentheses tells us we treat it as a single value. So this is being multiplied against this, and this, and this. So it could be, we could say A, B, C, and D. And by being commutative, which multiplication is, it means we can switch it around any way we want. It could be A times B times C times D. It could be D times C times B times A. And any other configuration you can come up with. So even though these aren't right next to each other, we can go ahead and cross cancel those hours. Okay? So that's an important thing to remember right here. Now, minutes is certainly easier than hours to convert to seconds in terms of their closeness, right? They're much a minute's much closer. It's a second's 1/60th of a minute versus 1/3600th of an hour. So that's why we converted it to minutes right here. And we're going to go ahead and put this up here, and we're going to say what we're after. So we move diagonally so we can cross cancel, don't we? So we're going to put 1 minute is 60 seconds, or 1 minute per 60 seconds, right? And again, we were thinking ahead, we were setting ourselves up to be able to cross cancel those units of measurement, right? Now, we've talked about this before, and you'll hear me say it again. 1 is the multiplicative identity, okay, remember that. I just like you to know the terminology that you should know. So there's a 1, there's a 1, and here's another 1. So those are negligible in this multiplication problem. So we have a multiplication problem, and they are fractions, so we just go numerator multiplied by numerator, denominator multiplied by denominator, right? So 231 multiplied by 1 is 231, multiplied by 1,000 is 231,000, multiplied by 1 is 231,000, multiplied by 1 is 231,000. So we're going to come down here and we're going to write 231,000, okay? But what? 230, I've said this before, a number is just a number without a unit of measure. It's meaningless, right? So let's look. Everything's canceled out. Oh, there it is. There's the last remaining unit of measure in the numerator position. So we're going to go ahead and put meters there. Now per, this is where we're at. We're at that per symbol, right? Now let's carry out the denominator multiplication. So we have 1 times 0.62, which is 0.62 times 1, which is still 0.62, times 60 times 60. And I already carried that out on my calculator, and that was 2232. I didn't do that in my head. I wish. That would have been awesome. So 2,232. Let's look. Hours are canceled. That's canceled. That's canceled. That's canceled. Seconds. That's what's left. Okay, so here we are. We're at 231,000 meters per 2,232 seconds. That's not very palatable, not very easy to say, so it's not really the best way to turn that in. So we're going to go ahead and carry out that division, right? So 231,000 divided by 2232. And that comes out to 103, I think, 0.46, something like that. We're just going to round it to 103. 103 what? Meters per second. So we went ahead and we converted 231 miles per hour to 103 meters per second. So we put it in scientific proper SI format, right? We used the proper SI notation. So hopefully that helped, and you can see that we want to set it up so we're moving diagonally through our conversion factors so that we can cross cancel, right? Generally speaking, the measurement we're after, we're going to put in the numerator position whenever possible, okay? Here was the exception within that solution, but you've seen that what we had to do was put the minutes in the diagonal position so that we could cross cancel. And if you also notice, we converted for length from miles to meters and for time from hours to seconds in the same solution. So hopefully that was really helpful. All right, cheers.